Grouped data. Grouped data is a type of data that has been organized into groups or classes. Each group or class represents a range of values that fall within that group. Grouped data is commonly used in statistical analysis when the data is too large or too varied to be presented in individual values. Grouped data is usually presented in a frequency distribution table, which shows the number of observations that fall within each group or class. For example, a frequency distribution table might show the number of students in a school who scored within certain ranges on a test, such as 0 to 10, 11 to 20, 21 to 30, and so on. Mean from grouped data. To find the average or mean from grouped data, follow these steps. Write down the frequency distribution table that contains the class intervals and their corresponding frequencies. Find the midpoint of each class interval. To do this, add the lower and upper limits of each class interval and divide the sum by 2. The formula is midpoint will be lower limit plus upper limit over 2. Multiply each midpoint by its corresponding frequency. Add up the products obtained in step 3. Add up the frequencies from the frequency distribution table. Divide the sum obtained in step 4 by the sum obtained in step 5. The result is the average or mean from grouped data. Examination tips. When given with data in a table, it may be unclear if the data is grouped or not. When you encounter the term estimate the mean, you know you are dealing with grouped data. Therefore, utilize the midpoint strategy to answer the query. Worked example. Suppose you have the following frequency distribution table. To find the average from this data, write down the frequency distribution table. Find the midpoint of each class interval as shown in the table. Multiply each midpoint by its corresponding frequency. Midpoint and frequency, so their products are written in the fourth column. Now add up the products obtained in fourth column is 1710. Add up the frequencies equals 50. Now divide the sum from fourth column by the sum of frequencies. 1710 over 50 equals 34.2. Therefore, the average from the grouped data is 34.2. Median from grouped data. To find the class interval that the median lies in from grouped data, find the cumulative frequency of the data. This can be done by adding up the frequencies of each class interval starting from the first class interval. Determine the median value of the data. If the total number of observations, the sum of the frequencies is odd, the median is the value that is exactly in the middle of the data set. If the total number of observations is even, the median is the average of the two middle values. Identify the class interval that contains the median value. To do this, compare the cumulative frequency of each class interval with the median value. The class interval that contains the median value is the one for which the cumulative frequency is just greater than or equal to the median value. Worked example is, suppose you have the following frequency distribution table: class intervals and frequencies. Find the cumulative frequency by adding up the frequencies of each class interval, starting from the first class interval. The first cumulative frequency will be 8, then 8 plus 12 is 20, 20 plus 20 is 40, 40 plus 15 is 55, 55 plus 5 is 60. Determine the median value of the data. In this case, the total number of observations is 60, which is even. So the median is the average of the two middle values, which are the 30th and 31st values in the data set. To find these values, use the cumulative frequency. The 30th value falls within the class interval 10 to 15. The lower limit of this interval is 10 and the frequency is 20. So the 30th value is greater than or equal to 10 and less than 15. Now model class interval. To find the model class interval from grouped data, determine the frequency of each class interval in the grouped data. Identify the class interval with the highest frequency. This is your model class interval. If there are two or more class intervals with the same highest frequency, then you can consider them all as model class intervals. Range and interquartile range are both measures of spread or variability in a data set. However, they have different methods of calculation and provide different information about the distribution of the data. Range. The range is a measure of the spread of a dataset, calculated as the difference between the highest and the lowest values in the dataset. For example, if you have a dataset of exam scores ranging from 60 to 95, the range would be 35. The range is a simple measure of spread that provides an idea of how much the data varies from the minimum to the maximum value. Worked example. Suppose we have the following data set: 1, 5, 10, 15 and 20. To calculate the range, we subtract the minimum value from the maximum value, which gives us our range. So 20 minus 1 equals 19. So the range of this data set is 19. Interquartile range. The interquartile range is a measure of spread that is less sensitive to outliers than the range. It is calculated as the difference between the upper and lower quartiles of the dataset. The lower quartile is the value that cuts off the lowest 25% of the data, and the upper quartile is the value that cuts off the highest 25% of the data. The interquartile range contains the middle 50% of the data. For example, if the lower quartile is 25 and the upper quartile is 75, the interquartile range would be 50, 75 minus 25. The interquartile range provides information about the spread of the data in the middle half of the distribution, which is useful for identifying any potential outliers or skewedness in the data. Examination tips. Remember that you must perform a computation even if it is a simple subtraction with the range. It is not sufficient to state anything like the range is 14 to 22. The same is true for the interquartile range. Worked example. Suppose we have the following data set. To calculate the quartiles, we first need to order the data from smallest to largest, as shown. The median Q2 is the middle value. Q2 is 29. To find Q1, we need to take the median of the lower half of the data set, excluding 29. So the lower half is 7, 12, 18 and 23, and the median of that is 15.5. So Q1 is 15.5. To find Q3, we need to take the median of the upper half of the dataset excluding 29. So the upper half is 31, 36, 42, 46, 51, and the median of that is 42. So Q3 is equal to 42. So the quartiles for this dataset are Q1 is 15.5, Q2 is 29 and Q3 is 42. The interquartile range is the difference between Q3 and Q1, which is 26.5.